5 years. This is M. Samahadri, lecturer in statistics. Today I am explaining one of the important theorem in probability. This is called Bayes theorem. Okay, so I am explaining the history of Bayes theorem. Then after I will derive the this theorem. Okay, so after before start the Bayes theorem, we have to learn some concepts of probabilities. So generally there are two types of probabilities is there. The first one is called priori probability. One is called priori probabilities and second one is called posterior probability. There are two types of probabilities, priori probabilities and posterior probabilities. What is that? The difference between priori and posterior probabilities. Very simple. The priori probabilities otherwise called subjective probability. What is that? Subjective probability. Priori probability otherwise called subjective probability, and posterior probability otherwise called inverse probability. It's very important. Inverse probability. Okay, so what is the priori probabilities? Very simple. You know the definition of priori, definition of probability, or mathematical definition, or priori definition, or classical definition of probability. There is a general definition in probability. Okay, it's called subjective probability. Right, the probability is assigned to various events on the basis of past experience. Okay, this is a past experience or on the basis of person judgment is called priori probabilities. Okay, and next one is posterior probabilities. One may like to revise these probabilities in the new information or additional information. So the revised these probabilities are called posterior probabilities. Okay, so the probabilities can be calculated by using Bayes theorem. Okay, so posterior probability can be calculated using Bayes theorem. What is posterior probabilities? Adding some information to the priori probabilities. Okay, so what is priori probabilities? The basic information or basic definition of probability. Okay, so first we take the basic information probability, adding some information, apply the Bayes theorem condition. Finally, we get posterior probabilities. So the purpose of the Bayes theorem is to calculate the posterior probabilities or inverse probabilities. Okay, this is the cycle. Okay, so now I am explaining the theorem, the Bayes theorem. So this is the statement of Bayes theorem. Let E1, E2 and so on, E and B and mutually exclusive disjoint events. Okay, very important word, mutually exclusive events. With P of A not equal to 0, I is equal to 1 to 1 so on N, and S is equal to union of I running 1 to N EI. Then for any arbitrary event A such that A subset of union I running 1 to N EI and P of A greater than 0, then P of A given A is equal to P of A into P of A given EI divided by summation I running 1 to N P of A into P of A given EI. This is the statement of Bayes theorem, right? So now consider the Venn diagram. This is the very using the Venn diagram. First of all, consider the Venn diagram. That's the Venn diagram. See the Venn diagram. This is E1, E2 and so on, En are N mutually exclusive and disjoint events, right? So P of A not equal to 0, I running 1 to and so on N, and this is the sample space S is the union, right? It is very simple. Union I running from 1 to N EI. These are all events are union. Okay, then for any arbitrary value A, this is the one of the arbitrary value A, and such that A is subset of union I running 1 to an EI. So A is subset of union EI and P of A greater than 0, right? So I'm taking this, consider the Venn diagram since since A is subset of union I running from 1 to n 1 to n ei. This is the given information in this statement. A subset of union I running 1 to n ei. Okay, so now I'm taking A is equal to, okay, A is equal to, what is that? A is equal to A intersection of union I running from 1 to n ei. This is the important concept. This is the key concept. A is equal to A intersection union I running from 1 to n ei. Okay, this is the concept. Now that is equal to A intersection, what is the union of ei? So E1 union E2 union and so on union En, right? That is equal to, again separate that E intersection E1 union A intersection E2 union and so on union A intersection En, right? So now that is equal to union of I running from 1 to n A intersection ei. Okay, what is that? A is equal to, okay, now taking a probability both sides, P of A is equal to P of union I running from 1 to n A intersection ei, right? So now by apply the axiomatic conditions, so axiomatic definitions of probability. So by axiomatic definitions of probability, axiomatic definition of probability, that is called third axiom. That means that is called additivity axiom. Apply the additivity axiom. Okay, therefore P of A is equal to what is the third axiom? Not the union to summation. So summation I running from 1 to n P of A intersection ei. Okay, so now that is equal to summation I running from 1 to n. What is P of A intersection ei? So apply the condition probability concept. So this is P of ei into P of A given ei. Okay, this is equation number 1. So you know that P of A given ei is equal to the formula P of A intersection ei by P of ei. Okay, so here at the side P of A into P of A given A is equal to P of A intersection ei, right? This is the concept. So now the conditional, next one is the conditional probability, right? The conditional probability, the conditional probability of an event A, conditional probability of an event A, event ei, the conditional probability of an event ei given that A is very important. The conditional probability of an event ei given that A has already happened, already occurred, comma, is given by conditional probability of an event ei given that A is already occurred is given by, what is that? P of ei given a, okay, right? P of a given a is equal to, what is the formula? P of a intersection ei by, what is that? P of a, right? P of a. Now the P of a given a is equal to, and that is equal to, what is the P of a intersection a is equal to formula P of ei into P of a given ei by P of a. Okay, this is equation number 2. So using equation 1 and equation 2, okay, can be written as P of a given a is equal to P of e I given a is equal to what that P of e I into P of a given e I divided by, so what is P of a? P of a is summation I running from 1 to n P of ei into P of a given ei. Okay, this is called a Bayes theorem concept. Here observe that there are 3 terms. Okay, the first term, this is not important point, the first term P of ei, okay, this is the basic probability. It is called priori probability. What is that? This is called priori probability. This is called priori probability because they exist before we gain any information. This is called priori probability, right? Next one is called P of a given ei, okay, this is called likelihoods. What is that? This is called likelihoods. This is called likelihoods. What is likelihood? This is nothing but conditional probability, okay, but it is likelihood functions, sorry, these are likelihoods because they indicates how likely event a under consideration is to occur given each and every prior probabilities. Okay, this is called likelihoods. Next one is called P of ei given a is called posterior probabilities. It's called posterior probability because they are determined after the results of the experiment are known. It's called posterior probability, right? This is the Bayes theorem concept. Okay, next class, but again the new concept. Okay, so have a nice day. Bye.